Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our second lesson on a given Form 4 mathematics topic called integration. So we are looking at our fourth example, which is a past cases equation tested in 205, paper 1, question number 21. It reads that the gradient of a curve at the point xy is 4x minus 3. The curve has a minimum value of -1/8. Part A of the question, find Roman 1, the value of x at the minimum point. So we start by looking at part A, Roman 1 of the question. Now remember that at the minimum point or the maximum point or at the point of inflection, the gradient function must always be equal to 0. Remember, a minimum point is a stationary point, or what we are calling that is the point when the gradient function of the curve must always be equal to 0. Therefore, we'll say that at the minimum point, the gradient function dy dx must always be equal to 0. Then we are told that the gradient of a curve at the point xy is given by 4x minus 3. Therefore, we'll say that dy dx, which in this case is given as 4x minus 3, these must be equal to 0 at the minimum point or the maximum point or at the point of inflection, or what we call at the stationary point. Therefore, I'm going to pick the second part of the equation so that I get the value of x at the minimum point. Therefore, we'll say 4x minus 3 must be equal to 0, which implies that 4x will be equal to, of course, I'll take this one to the other side, so this will be 3. Dividing through by 4, I divide through by 4. It simply implies that my value of x will be equal to 3/4. Therefore, at the minimum point, the value of x will be equal to 3/4. Then we look at part B of the question, that is A Roman 2. So in A Roman 2 of the question, we are told to find the equation of this particular curve. Of course, the equation of the curve, we shall be forced to integrate the equation. Now, remember, we already have the gradient function, which is dy dx was equal to 4x, then of course minus 3. For us to get the equation, we just need to get the value of y. For us to achieve that, we're gonna multiply through this particular equation by dx. I also multiply this other side by dx, so that dx and dx are going to cancel out. Then from this particular point, it means that I'm remaining with dy being equal to 4x, then of course minus 3, then it's being multiplied by dx. Remember, we said that a multiplication by dx or dt simply means that you're supposed to integrate both sides of the equation. But a division by dt or dx means that you're supposed to differentiate. Therefore, if I integrate dy, I'm going to get y being equal to, if we integrate this particular part, of course, this one means it is x power 1. So I'm going to have 4x to the power of 1. To integrate means that you're going to add 1 to the power. Then, of course, we divide by the new power, which is 1 plus 1. Then this one means that it was x to the power of 0. Therefore, it means that I'm having -3x to the power of 0. Then, of course, I'm going to add 1 to the power. Then I divide by the new power, which is 0 plus 1. Then, of course, I'm going to add an arbitrary constant of integration. Therefore, y will be equal to, this will be 4x to the power of 1 plus 1, I'll get 2, divided by 1 plus 1, I'll still get 2. Then minus 3x to the power of 0 plus 1, I'll get 1, divided by 0 plus 1, I'll still get 1, then plus the constant. Therefore, y will be equal to, of course, by 2, 1, then by 2, this will be 2. It means that my equation will be y is equals to 2x to the power of 2, then of course minus 3x, then plus the constant of integration. So to get my equation, I need to get the value of this particular constant. Now remember that at the minimum point, will be my x coordinate at the minimum point is 3 over 4. So this is 3 over 4, comma. Then I'm told that the curve has minimum value of negative 1 over 8. Of course, the curve must always start with y is equals to something. Therefore, this one is telling us that the coordinate of y at the minimum point will be negative 1 over 8. Therefore, my points are 3 over 4, comma, negative 1 over 8. Therefore, this is the x coordinate and this is the y coordinate. So I'm going to substitute in this particular equation so that I get the value of c, which is actually our constant. So on substituting, this is what I'm gonna get. So my y is negative 1 over 8, which is equals to 2 into my x, of course, is 3 over 4. Then it was x squared, so this will be squared. Then minus 3 into x, of course, my x is 3 over 4. Then, of course, plus the constant of integration. So this will be negative 1 over 8, which is equals to 2 into 3 squared will give me 9. Then, of course, 4 squared, this is 16. I close the bracket. Then minus 3 by 3, I'll get 9, of course, over 4. Then plus c. So this will be negative 1 over 8 being equal to 2 by 9, that is 18 over 16 minus 9 over 4, then of course plus c. So clearly the value of c will be equal to negative 1 over 8. If this crosses equal sign, it becomes a negative 18 over 16. If this crosses equal sign, it becomes a positive 9 over 4. So c will be equal to, I find the LCM of 8, 16, and 4. Of course, the LCM will be 16. 8 into 16, that is 2. 2 times negative 2, I'll get negative 2. 16 into 16, 1 times negative 18, I'll get negative 18. 4 into 16, that is 4 by 9. That will give me positive 36. Negative 2 minus 18, that will give me negative 20. Then, of course, plus 36. Plus 36 over 16 is equals to c. Negative 20 plus 36, that will give me positive 16, of course, over 16, which is equals to c. It simply implies that my value of c will actually be equal to 16 over 16, of course, which will be equal to 1. Now, having gotten the value of c, we can now get the equation of this particular curve, of course, which will be given by, so I'm simply going to substitute the value of c in my equation to get the equation of the curve. Now, the equation of the curve, it was this one here. So it was y is equals to 2x squared, then of course minus 3x, then of course plus c. Therefore, this will be y is equals to 2x squared minus 3x, then plus c. My value of c is 1. Therefore, this was the equation of the curve. Then we look at part B of the question, whereby we are told that P is a point on the curve in part A Roman 2 above. If the gradient of the curve at the point P is negative 7, find the coordinates of P. Since we already have the gradient function of this particular curve, which was dy dx is equals to, we were given the gradient function as 4x minus 3. dy dx was 4x, then of course minus 3. Now we are being told that at the point P, the gradient of this particular curve is negative 7. Therefore, at the point P, this dy dx must give us negative 7. So on solving this particular part here, we can get the x coordinate. So we have 4x minus 3, which is equals to negative 7, which implies that 4x will be equal to, I'll take this to the other side, so this will be negative 7, then of course plus 3. Therefore, 4x will be equal to, this will give me negative 4. I divide through by 4. I also divide through by 4. The two 4s will cancel out. Therefore, x will be equal to negative 4 over 4, which clearly will simplify to negative 1. Therefore, our x will be equal to negative 1. But remember, the question wants us to find the coordinate of P. A coordinate is made up of the value of x and y. Therefore, since we have the value of x, we just need to get the value of y. We already had the equation of y, which was y is equals to, it is here, 2x squared this is 2x squared, then of course minus 3x, then plus 1. So minus 3x, then plus 1. Therefore, we'll substitute when x is negative 1. So y will be equal to 2 into, that is when x is negative 1. So this will be negative 1 squared, then minus 3 into negative 1, then of course plus 1. So y will be equal to 2 into negative 1 squared will give us positive 1, then minus 3 into negative 1, then plus 1. So this will be positive 2. Negative 3 times negative 1, I'll get a positive 3, then plus 1, which will be equal to 2 plus 3, that is 5. So this is 5 plus 1, which will give us 6. Therefore, it means that the point P must be given by x comma y, of course, which will be, P will be, our x is negative 1, then of course y is equals to 6. Therefore, this is the coordinate of the point P. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.